Okay, next up we have Ayesha, and if you haven't, I'm sure everyone has seen it actually. The display right in the middle in the front is awesome, and I'll let you take it away. Here you go.
Oh, thank you. This is my first Teardown, and it's been so great, and everyone's been so awesome. So thank you for being so cool. Yeah. Um, this is not a super technical talk. The title has pretty in it, so if you're not scared already, so that's awesome. Good for you. I'm just here to talk about PCBs. They're typically called printed circuit boards, but I like to call them pretty circuit boards. And I use them for STEM outreach. Gotta go clicky click. If anyone doesn't know me, which I'm new, so most people probably don't, I'm an electrical engineer. That's my full-time job. I've done a bunch of projects. I've made IoT sensors for dishwashers to monitor energy and water consumption. I've designed BMS and motor control circuits for Ryobi to help them move away from gas-powered tools. I've worked at a startup for strawberry harvesting. That's to grow our food more sustainably and help farmers to grow food in like hydroponic grows and like do UV disinfection instead of like chemicals. So that was really fun. And recently I helped to design the first all-electric RV, which was completely solar powered and battery powered. And I was the only electrical engineer there. So that was kind of fun. But I often found myself as the only in a lot of engineering rooms, so that got me drawn into outreach work. So I do a lot of youth mentoring because talent and opportunity is not very equally spread out in the world. So it's kind of important to help kids who don't usually get like that. They don't get to see engineers and scientists in their everyday life to go out to them and show them what it looks like. And then like the people who do make it into STEM careers to give them the resources so they can stay there. And the companies who hire them do the right thing so they get to thrive in those environments. And my own imposter syndrome is what led me to this awesome community. I started making projects just for fun so I could learn from them and like have a safe place to fail, like ask questions. And I found this community and I started making things for fun. So my topic is about PCBs, and I'm curious if, I guess, raise your right hand if you've ever designed a PCB. Pretty much everyone, awesome. Raise your hand if you've ever been scared of PCBs, like intimidated to get started. Everyone in the room, not surprising. So I mentioned that I'm an electrical engineer. Whoa, no, we're going ahead. But the first time I started working as an electrical engineer was the first time I was exposed to PCB design. Even though I went through the traditional engineering path, no one taught me how to do it. So I went to my first job, and I was like, maybe they hired the wrong person, and I was really scared. But then I taught myself how to design PCBs, even though that's like the major chunk of my jobs. I kind of waiting for that refund from my engineering education. Still haven't got it. But I started talking to other engineers, and I found out that this is a common problem. And I think it's mainly because of these reasons. They're not taught in schools, they're not universities. The resources are very limited and not very accessible. That's changing, which is awesome. And PCBs are everywhere, but they're often hidden, so they're not accessible, and that's how a lot of people like to learn. I'm sure that's how most people here like to learn, by actually looking and playing with them. So that's already a barrier, and it's just intimidating to get started because there's just so much to do. So I found that when I started doing STEM outreach, when I would show up with these crazy-looking circuit boards that I designed in my engineering job, no one really cared. They were like, good for you, not for me. That sounds well. And then I started showing up with my PCB badges, and like kids, adults, everyone were just interested. They were asking interesting questions on how to do it, what tools to use, what colors, what patterns, and it just like got them interested in engineering, which was an awesome tool. So I started thinking about how I can leverage this to get more people interested in engineering and PCB design, and this is kind of my method that I've kind of formulated. So before everything, let's define what a PCB is. Let's address it, right? So PCBs are just like a way to make electrical connections of all the electronic components, give a mechanical support for these components to sit on, to make like somewhat of a permanent connection and create cool things with it. And I'd argue that making PCBs is as simple as making a sandwich. Um, so let's see what a PCB sandwich has. So the first layer of our PCB sandwich is a substrate, which is a layer of fiberglass. And we know that glass is not a conductor, it's an insulator. So the glass is just providing mechanical support, we have that. But we need conductors to make our electrons flow, because that's where all the magic happens. So the next step of the sandwich is to add conductors, which is thin copper sheets that are pressed on the PCB. And now we have electrons, like they can roam around, live their happy life. But we don't want to separate them in the layers, so we can do cool things like drill holes and plate them. So the electrons have like a little tunnel where they can flow around. And then we can etch them, so they have like little highways and roads where they can go more constructively. And then we make little pads, so like all the components have little houses where they can sit and they can be soldered. So we have a PCB kind of, but we want to also protect the roads and the highways, the traces that are on the PCB, so we can add solder mask, which is a protective layer, so that like you don't accidentally short the components, so you don't like dust and humidity doesn't affect the PCB. So we have that added. And then we add ink, which is more for information to mark all the components, but you can also add graphics to it. So we have the PCB, but we also have a fun little palette to play around with. So we have all these layers and the colors, so we can pick and choose and make art with it. So once I started realizing that, I started making art, and this is kind of my process of like making pretty PCBs or pretty circuit boards. Oh, you can also add LEDs. We all love LEDs to add even more color. Yeah. And if you don't like LEDs, like, I don't know, go touch some grass. Okay, so the process for, huh? Oh, sorry, I was like, hot take? No. Okay, so, oh, no. So while designing PCBs, I started with thinking of what components do I want. So I just want to turn on 3 red LEDs, that's all. Pick the LEDs. I want a power source. I want to do coin cells, so I'm going to pick a coin cell. I want to limit the current, because I don't want it to take off all the current at once. So I add resistors. And I want a way to control the current. Like, I want to turn it on and off, so I add a switch. So I made the schematic, which is what the left side looks like. And then I import it into a PCB, which is what like the real representation looks like, and do that. But we don't like square PCBs. They're boring. So we're going to make a fun shape. We're going to put it on a rocket. And then we're going to think about how we want to place it to make it look aesthetic and like make it make sense, make all the connections. And then we'll have fun with it. So we're going to decide what color we want. So it's a rocket, so I'm going to do white color and then add some fun graphics to it. So this is kind of the process that I use to make pretty circuit boards. And then I wanted to do more with it, like more good, spread happiness, whatever. So I started partnering with nonprofits who do all the heavy lifting of the outreach work. So all I do is show up with my circuit boards to help them reach their goals. So one of the things I did with this batch of PCBs is partnered with an organization called Reinvented Magazine, who hosts a Space Gala. It's a fundraiser to raise money for after-school programs, especially for girls and non-binary youth. So we made these kits and we sold them as jewelry and just soldering kits. And we had this cool event where like a bunch of women who are scientists and engineers showed up in sparkly gowns, danced in NASA, and raised money to help the next generation of girls to get into STEM, which was very awesome. Um, and then I designed these Lily PCBs, which was for a workshop to teach programming. So it was a CircuitPython workshop, and we taught a group of kids to program NeoPixels. And I made it into a flower shape, so they get to keep it. And this was around Valentine's Day, so that was the idea. So they can make their own flowers, and they get to keep it, and have something awesome to look back on. This was a project I did with Reinvented magazine where they made a calendar called Princesses with Power Tools, where we reimagined classic princesses as women in STEM. I was Cinderella, and I was building my own crown, and like I had my own butterfly PCBs on my dress. No fairy godmother, no prince. We can do it on our own. So this was a fun little project, and once you put on a ball gown and like solder on the internet, there's nothing anyone can say that'll hurt you. So that was really cool. Like I got to do that, and we made these calendars, and we donated 1,500 to schools. That was seen in mostly Title I schools, which was 150 classrooms, so like 80,000 students that we know of, and there were like over thousands of like individual sales, which we don't know what happened, but hopefully went to more schools. So that was kind of cool. This was a jewelry project because I roller skate. I just made myself some PCB earrings. And once I started wearing them, like usually they're kids in skate parks. So they would ask what those are, and I would start giving like my 5-minute spiel about PCBs and how they're related to like the circuit boards inside my phone, and they got really excited. And then there was a skate park that was getting torn down. So since seeing like the community was so interested in these, I donated a bunch of these to the skate shop, and we used that to raise money to save the wood from this bowl that we all really liked. So that was really cool. And just seeing like that overlap between skating and engineering, I decided to make this circuit board, which has like a nano on it, and so has an accelerometer and a neopixel. So we could. My idea was to show how physics is used in the skate park and in engineering to make it more approachable. It's not a project I finished, but I really want to teach like a workshop or something with it, targeted towards kids who skate or adults who skate, whoever. This was a Pikachu LiPo charger that I made because I wanted to stop using coin salts in my projects, which I still haven't completely, but I wanted an easy way to carry my LiPo charger, which was cute, so I wear it as a pendant, and I don't know, I really like it. A lot of people really like it, and it's just a fun way to talk about LiPo batteries and why it's better than coin cells in some ways. This was a cool workshop. I just made this for myself. I turned a bookmark into a book stand, like a light, but it was just using simple materials, just copper tape and paper. And I thought a workshop for this, and this was probably the best workshop I've personally thought, because it was just so accessible, where people could just build PCBs with simple materials, and like the idea just delivered. Again, so this was from Open Hardware Summit when I went for the first time last year. That was my first conference, and I spoke to a bunch of like e-textile artists, and they've all were talking about how they really want to use more LEDs, but they don't want to get into programming just yet, and want to be able to change colors. So I thought this would be cool to make like a sewable PCB with just potentiometer, so you can color mix, and for them to get into electronics and then figure out if they want to do programming later on. I'm trying to figure out how to make this accessible or like sell it, or it's a work in progress, but I like what it became. And then this is a RP2040 sewable board that I designed, because IP2040 is right now my favorite chip to work with, and there wasn't a suitable version of that. So I started working on this, and that led into making these little friends for the Pico Daisy. The Pico Daisy is the board, so it can so we can test like buttons and buzzers, the peripherals with the board, and make that turn that into a kit eventually. So the idea is to turn it into a circuit board that people can test on and then break it apart and have it. It's a work in progress, hopefully soon. But all this is cool, but this is why it really matters. The representation in engineering is awful. It's actually Women in Engineering Day today, so yay. But this is what the statistics look like, and it's not a fair representation of the consumers versus people who are designing it. And this further extends to race, which is also not great. And then also to age, which was surprising to me, but then thinking about it and the gap of mentorship and not things not being accessible, there are fewer people getting into PCB design, but we need PCBs, so it's a problem. So I think the pretty circuit boards are a little bit more than just pretty circuit boards. They are helping to promote diversity in STEM spaces and maker spaces. They're a way to set foundations for more complex designs. And just having people experiment with things, that's how any innovation happens, breakthroughs happen. So it's a fun way to promote that. And then it just promotes self-reliance. It just teaches people how to get comfortable with electronics so they can build their own things, repair their own things. E-waste is like the biggest growing solid waste right now. And just having everyone have that skill to just understand PCBs and be comfortable with it and repair it, it's just going to help solve that problem in hopefully a fun way. So I think that's all I had. Oh, yeah, call to action. What can you all do? So my friends here who said that you've never designed a PCB, I know it's hard to get started, but what you can do is maybe just pick up a PCB, take an X-Acto knife, scratch a few things, figure out what PCBs are made of. If you wanted to design a PCB, there are resources now. Look into it. And if you're designing it, share your process, share your methods, and just think about teaching PCBs. It doesn't have to be an organized classroom. It can be unconventional ways. So yeah, that's all. That's all I had. Thank you. Oh. Any questions? Yeah.
First of all, I have one of those Ryobi mowers that you had on your first slide, and it's great. It just works. But the question was, have you found any PCB suppliers who will do like multiple colors of ink and or solder mask, and like how does that process work?
JLC, whoa, my mic just started working. Did you hear me till now? Yes. Okay. JLC is starting to do multi-silk screen PCBs now. I don't know the supplier, but Steph Piper does like the multi-solder mask PCBs. And she just made a video on Instagram explaining that process. So I'd recommend looking into that. Yeah. PCBWay also does it. Yeah. Right. Any other questions?
I'm curious, do you design all of your own artwork, or do you like use clip art, or what is your process there?
I do a mix of things. So I don't sell it, so that's one thing that gives me a little bit more freedom. I do use most of my own, but I do use like clip art and other open source or like non-licensed artwork. Yeah.
I saw that you said you reached out to like nonprofits and worked with STEAM at Title I schools and stuff. Like, how did you figure that out? Did you like reach out to the nonprofits and say, this is what I want to do? Or how did you figure that part out?
Yeah, that's a question I get a lot. So the first thing I did, there was an organization called ChickTech that was in North Carolina, and they were doing programs, and they were looking for volunteers to just show up the day off and like help out. And once I went there, I started talking to them, and next year I started doing programs with them. And then once you kind of get in, they have friends, and then you just kind of make yourself your way into the community. Reinvented magazine, I just really liked them, so I started talking to them, and I wrote an article for them and just found my way through that. Yeah. I guess the short answer is find an organization, do work for them, and then they'll want to work with you even more. Yeah. Any other questions? Cool. Thank you.